Okay, welcome. And so today we're going to talk about, we're going to start a new section, and this is going to be regarding things, characteristics about graphs. And what we're going to start is with basic functions and their graphs. So there are going to be several types of functions that you're going to need to know that help you graph functions. And if you know these basic functions, or some people call them the toolbox functions, because if you take these 6 or 8 functions, these are represent general families of functions, then you'll be able to know by looking how to graph them, because you'll know what the parent function is. We'll get to what a parent function is, but we're going to also talk about, hey, how do we graph these basic functions? Okay, so but before we can do that, we're going to start with obviously some definitions and concepts. And so in this section, in this chapter, we're going to talk about continuity today. Okay, so when we talk about continuity, what do we mean? Okay, so we're not going to give the technical definition for continuity right at this point. We're going to give an informal definition that's very intuitive, very easy to understand, and this is what it is. Okay, so continuity means that, hey, if you take a function, so a function is continuous, so if there is continuity, if it is continuous, right, that's what the term we're going to use. So a function is continuous over an interval of its domain if its hand-drawn graph over that said interval can be sketched without lifting your pencil from the paper. If that's the case, then we would say we have a continuous function. If you can't do that, then it's not continuous or discontinuous. Okay? So for example, here's just some examples that I wrote on. So again, here's a graph. Okay? If we look at the graph of this function, then we can see that we could take our pencil and we could sketch this graph. We can run our pencil along this graph and never have to lift our pencil up off the paper. So this would represent a continuous function. Okay? Looking at this graph here, we see it's a straight line, and again, we can take our pencil and we can sketch or run our pencil along the graph, and we don't ever have to lift our pencil. Okay? So this would also represent a continuous function. Okay? Now this one here, if you notice that you can take your pencil and you can trace this graph up to this point where there's a hole in the graph. And at this point you would have to jump over the hole, thus lifting your pencil off the paper, and then continue on. So this would be an example of a discontinuous function, okay, or a function that is not continuous. And so the thing is that if there are any holes, any jumps, any breaks, then we would say that it's not continuous. Okay, but if you can basically trace the graph without ever lifting your pencil off the paper, then you have a continuous function. Now that's using visuals. Okay, so we're going to talk about, hey, how do I look at a function like the algebraic expression to determine whether it's continuous or not, and that's going to come later. But this will give you a great idea of where to start from, because a lot of functions you can see, or you can get a feeling or an intuitive idea of whether they're continuous or not. Okay, so again, we're going to talk about the basic toolbox functions, basic functions, and we're going to talk about, hey, where are they continuous? Also, we might be interested in only a small subset of the domain, right? So a function could be continuous on an interval, right? We don't necessarily need to consider the entire domain. For example, even though this is a discontinuous function, if we talk about the entire domain, if we limit our interval, let's say we're only interested in this interval, right, from A to B, then on that interval, the function is continuous. So it depends on the interval we're interested in as well. But again, if we're talking about the entire domain, right, then we would say this is discontinuous on the entire domain. But if we're just interested in an interval, a smaller interval of that domain, a subset of the domain, then in this case it is continuous. So that's also important. We're talking about a particular interval, okay? So again, you'll have to read the problem, and the problem will either say, hey, on this interval, right? So it'll give you the interval, or it'll say on the domain, which means then you have to consider everything. Okay? That's it. Have a great day.